Hello all. So today we're talking about Chapter 6, Part 3, Ergogenic Aspects and the Health Implications of Protein. So given the potential importance of protein to optimal physical performance, a wide variety of ergogenic aids associated with protein nutrition have been used in attempts to enhance performance. Such supplements remain popular. As Lawrence and Kirby noted, protein, amino acids, and creatine were among the top 5 most popular sports supplements. So what types of special protein supplements are marketed to physically active individuals? As already discussed, some investigators suggest that athletes involved in weight training to gain weight or in strenuous endurance exercise may need somewhat more than the RDA for protein to maintain or increase protein balance, particularly if energy intake, calories, is not adequate to meet daily energy expenditure. To provide additional protein to the diet, investigators have used high-protein diets, powdered protein sources, canned liquid meals, high in protein and energy, sports drinks, and bars, or special foods and concoctions high in protein content. However, the protein content is actually derived from natural protein, such as milk, egg, or soy protein. As Bucci has indicated, supplements of intact proteins, such as the proteins found in these products, offer no advantages over protein found in other food sources. Since these supplements are, in fact, derived from natural foods, in addition, many of these protein supplements are expensive when compared to natural protein that may be obtained easily in high-protein foods, such as powdered milk, skim milk, eggs, and chicken. Blending powdered milk into a glass of skim milk with some vanilla or other flavoring will provide substantial amounts of high-quality protein, your own personal protein supplement. Nevertheless, commercial supplements may be a convenient means for some busy athletes to secure additional protein in the diet. Many of these products contain high-quality protein, such as milk, whey, or egg protein, provide a balanced mixture of protein, carbohydrate, and fat for additional calories, and may also contain supplemental vitamins and minerals. Although these products do not contain all the nutrients of natural foods, they may be useful adjuncts to a balanced diet. Certain brands have been available for years, such as Nutriment, but several companies have marketed products specifically for physically active individuals, such as Mega Whey by GNC and Nutrition Shake by Gatorade. It is important to re-emphasize that the point that these supplements should be used as an adjunct to an otherwise balanced nutritional plan, not as a substitute. Whey and colostrum are 2 forms of protein that are sold as dietary supplements and marketed as a means to enhance sport performance. Whey proteins are extracted from the liquid whey that is produced during the manufacture of cheese or casein. Whey protein isolates are more than 90% protein. Hayes and Cribb note that whey protein are a rich source of essential amino acids, thus providing the foundations for preservation of muscle mass. Walsum and others note that bovine whey may contain other substances, including growth factors. Colostrum and bovine colostrum is the first milk secreted by cows. Standardized preparations of colostrum are available as dietary supplements. Brinkworth and others indicate that colostrum is a rich source of protein, carbohydrates, vitamins, minerals, and various biological active components, also including growth factors. Although no mechanism has been identified, one theory involves increased levels of serum insulin-like growth factor, or IGF-1, which could be anabolic. However, Coopers and others provided 60 grams of colostrum daily for 4 weeks to endurance-trained athletes and found no effect on blood IGF-1 or IGF-binding protein levels. Other protein substances, such as spirulina, which is algae, brewer's yeast, specific enzymes, and even DNA and RNA have been advocated as a means to improve physical performance. Spirulina and brewer's yeast are good sources of protein and a variety of vitamins and minerals, but convey no magical ergogenic qualities. The enzymes DNA and RNA would be degraded in the digestive process and thus could not be utilized for the purpose for which they are ingested. This is just a comparative of costs for different sources of protein. You can see powdered milk is 23 grams of serving size. They get 8 grams of protein per serving, and the cost is about 13 cents. per serving. Cost for 8 grams of protein is about 13 cents. If the most expensive are the protein capsules. There's 8, one serving size is 8 capsules, and you get 8 grams of protein per serving at $1.20 per serving, at $1.20 per 8 grams of protein. Another really expensive is the Met RX bar, which is a 3.5 ounce bar. It contains 27 grams of protein, so really high there, and $2.50 per serving. So the cost per 8 grams of serving is about 74 cents. Another really expensive is the Avalanche Power Drink, which is 16 fluid ounces, and you get 40 grams of protein per serving, so really high there. The cost is $3 per serving, or if you look at it per 8 grams of protein, it's about 60 cents. So protein capsules tend to be the most expensive from what it looks like here. So do high protein diets or protein supplements increase muscle mass and strength in resistance trained individuals? Some athletes in training may need more protein, and as noted below, some may increase muscle mass and strength with resistance training and protein supplementation. Moreover, some studies suggest that protein and carbohydrate beverages consumed during resistance exercise may help reduce muscle tissue damage and soreness. Given the possibility of enhanced muscle repair, consuming some of the recommended daily amount of protein immediately following exercise may be a prudent behavior. Whey and cholesterol. Research findings reveal mixed but generally positive effects relative to the ergogenic potential of whey supplementation to resistance-trained individuals. However, other protein sources were often combined with the whey protein. Several studies have evaluated the ergogenic effect of cholesterol supplementation using whey protein as a placebo to reveal whether cholesterol supplementation produced any benefit beyond those attributed to whey protein alone. Hoffman and others evaluated the effects of bovine cholesterol on body composition in 4 tests of exercise performance in elite male and female field hockey players. The tests included 2 shuttle sprints of 50 and 300 meters total for time, a shuttle sprint test to exhaustion, and a vertical jump. The subjects consumed 60 grams of cholesterol daily for 8 weeks, and whey protein served as the placebo. The cholesterol had no effect on body composition or 3 of the 4 exercise tests, but did appear to improve performance in the 50-meter shuttle sprint test. Antonio and others investigated the effect of 20 grams of bovine cholesterol given daily 8 weeks of aerobic and heavy resistance exercise training on body composition, strength, and aerobic endurance. Whey protein was the placebo. There were no effects of the cholesterol on exercise performance. The whey group significantly increased total body mass, whereas the cholesterol group, although not increasing total body mass, did increase lean body mass, which was attributed to a slight decrease in body fat. Brinkworth and others, studying the effect of other bovine cholesterol and whey protein supplementation, about 60 grams daily during 8 weeks of resistance training, found that subjects in the cholesterol group increased arm circumference and cross-sectional area, but the increase was principally due to a greater increase in skin and subcutaneous fat. Do high protein diets or protein supplements improve aerobic endurance performance in endurance-trained individuals? Protein supplementation may also help reduce muscle tissue damage and soreness during aerobic endurance training, but there is little evidence to support a performance-enhancing or ergogenic effect on aerobic endurance following acute or prolonged protein supplementation. High-protein diets or meals, the 40-30-30 or the zone diet alluded to in Chapter 5, may be considered to be a high-protein diet because 30% of the daily calories are derived from protein. There's a high end of the AMDR. So 40% are derived from carbohydrate and 30% are derived from fat. The premise underlying the zone diet is a change in hormonal activity, resulting in vasoactive eicosanoids that permit greater oxygen delivery to the muscle, a condition referred to as the zone. In a review, Chevrant criticized the zone diet book, noting that the claims of improved sport performance are based on anecdotal reports and selectively quoted research, not on sound scientific evidence. Chevron states that in actuality, reliable and abundant peer-reviewed literature is in opposition to the suggestion that such a diet can support competitive athletic endeavors, much less improve them, and even suggests that the zone diet may actually be ergolytic in nature. Some evidence does indicate that high-protein diets at the expense of carbohydrate may impair endurance performance. Nevertheless, for weight-restricted athletes attempting to lose body fat or maintain low body weight for sports competitions, some investigators recommend increased protein intake. With the 1,500 calorie diet, a 30% protein allotment would be 450 calories, or approximately 112 grams of protein. For a lean athlete, this amount of protein may help ensure protein adequacy and may fall in the range of recommended protein intake. In summary, Lemon notes that although endurance athletes may need a higher protein intake, 1.2 to 1.4 grams per kilogram of body weight, than sedentary individuals, these recommendations are based on protein balance studies as compared to the RDA of 0.8 grams per kilogram will enhance sport performance. Such studies are still needed. Various sports drinks containing both protein and carbohydrate have been marketed as a means to enhance performance when consumed during exercise and to facilitate recovery and improve subsequent exercise performance when consumed after exercise. Other studies do not support an ergogenic effect of protein carbohydrate supplementation when compared to carbohydrate supplements containing energy. As noted previously, consuming protein and carbohydrate following exercise provides a milieu conducive to induced anabolism, which is building of the muscle, and muscle recovery. Some have contended that ingesting carbohydrate plus protein followed prolonged exercise may restore exercise capacity more effectively than ingestion of carbohydrate alone. When the energy content is similar, consuming protein carbohydrate meals or supplements during recovery as compared to carbohydrate alone has no effect on subsequent exercise performance. Coombs and others evaluated the effect of different colostrum dosages on two tests of aerobic capacity in competitive cyclists. The dosages included 60 grams of colostrum and 20 grams of colostrum plus 40 grams of whey protein and 60 grams of whey protein, which was the placebo group. The exercise tests included two VO2 max tests with a 20-minute interval between each, and a cycle time trial test following 2 hours of cycling at 65% of VO2 max. Although performance in the VO2 max test was not improved by colostrum, it did provide a small but significant improvement in the time trial performance. Shing and others also noted some ergogenic effects of colostrum supplementation over the course of 10 weeks of training, including a final 5 days of high-intensity cycling. Highly trained male road cyclists consumed either a placebo or a daily supplement containing 10 grams of bovine colostrum protein concentrate, or CPC. A 40-kilometer time trial was done periodically to evaluate performance. The effects of the colostrum supplement on cycling time trial performance during the first 9 weeks of regular training was unclear, but performance of the colostrum group was enhanced significantly following the 5 days of high-intensity training. They reported that the CPC helped to maintain the ventilatory threshold, as with the effects of colostrum on strength-type activities. These too should be considered preliminary data. Confirmation with additional research is needed. Shing has stated that there is limited evidence supporting an ergogenic effect of colostrum and that because it may contain prohibited substances, it could affect the outcome of doping tests. So we're skipping to the end of the chapter and going over dietary protein and the health implications associated with that. We'll pick up on the other in another recording. So the acceptable macronutrient distribution range for individuals has been set for protein based on evidence from interventional trials with support of epidemiological evidence to suggest a role in the prevention of increased risk of chronic diseases and based on ensuring sufficient intakes of essential nutrients. As noted previously, the AMDR for protein is 10 to 35% of energy, and slightly lower percentages were set for children, about 5 to 20% for young, and 10 to 30% for older children. There may be several adverse health effects when consuming a diet which is consistently outside the AMDR for protein. either too low or too high. Excess intake of individual amino acids may also pose health risks. You can go to choosemyplate.gov and click on tips and resources, then go lean with protein and the nutrients and health implications for more information on protein food choices and your health. A short-term protein deficiency, several days, is not likely to cause any serious health problems, mainly because body metabolism adjusts to conserve its protein stores. However, because protein is the source of the essential amino acids and because protein-rich foods also contain an abundance of essential vitamins and minerals, a prolonged deficiency could be expected to cause serious health problems, such as the case in certain parts of the world where protein intake is inadequate for political, economic, or other reasons. Protein calorie malnutrition is one of the major malnutrition problems in the world today, particularly for young children. Infections develop because the immune system, which depends on adequate protein, is weakened. Death is common. For children who survive, physical and mental growth may be permanently retarded. Protein deficiency may also occur in individuals who abuse sound nutritional practices, such as drug addicts, chronic alcoholics, and extreme food fattists. But adults are more likely to recover fully with adequate nutrition. Elderly individuals, those over 65, may be more prone to protein undernutrition because they may eat less protein-rich food and may use protein less efficiently. Houston and others reported that in elderly men, protein intakes greater than the RDA seem to help conserve lean body mass, particularly skeletal muscle tissue. Leonard indicated that protein undernutrition in the elderly may impair immune function, making them more susceptible to infections. Adequate protein also plays an important role in bone development, thereby influencing peak bone mass. Bonjour and others note that low protein intake can be detrimental for both the acquisition of bone mass during growth and in its conservation during adulthood. Low protein intake impairs both the production and action of IGF-1, an essential factor for bone longitudinal growth. Protein intake is especially important during childhood, but it is very important during adulthood as well. According to a review by Gaffney, Stomberg, and colleagues, between 32% and 41% of women 50 years of age and older consume less than the current RDA of 0.8 grams of good quality protein per kilogram of body weight per day. This is higher than the 22 to 38% men in the same age group who do not meet the protein RDA. This is a particular concern given the loss of muscle mass or sarcopenia seen with aging. Gennaro and Martini found that sarcopenia in the elderly is associated with decreased metabolic rate, increased risks of falls and fractures, and thus increased morbidity and loss of independence. Individuals who are on a low-protein diet plan or young athletes who are on modified starvation diets to lose weight for such sports as gymnastics, ballet, or wrestling may experience periods of protein insufficiency. During this time, the individual may be in a negative nitrogen balance. That is, more nitrogen is being excreted from the body than is being ingested. Body tissues such as muscles and hemoglobin may be lost, with a possible reduction in strength and endurance capacity. Adequate protein intake is essential for proper physiological functioning and health, both in the inactive and active individual. Several major health problems associated with excessive weight loss, both in non-athletes and athletes, are related to both energy and protein balance. The role of protein in weight control, both weight loss and gain, will be discussed in chapters 10 through 12. In brief, diets rich in protein could help promote weight loss by increasing satiety and curbing the appetite, while also increasing thermogenesis and energy expenditure. Protein may also help promote weight gain by maintaining muscle mass. Does excessive protein intake pose any health risk? As associated or noted in previous chapters, the intake of even small amounts of food protein may be hazardous to individuals susceptible to food allergies or food intolerance. Certain proteins found in common foods, such as milk, fish, eggs, shellfish, peanuts, and wheat, may cause symptoms such as abdominal pain, gas, bloating, and diarrhea, even an anaphylactic reaction, which may be fatal. However, dietary protein intake normally does not cause any health problems with most individuals. Billsborough, a man, noted some dangers of excessive protein intake, such as elevated blood levels of ammonia and insulin, but noted that healthy individuals appeared to adapt well to highly variable dietary protein intakes. Frank signs of symptoms of amino acid excess are observed rarely, if at all, under usual dietary conditions, although the National Academy of Sciences did not establish a UL for protein. The upper level of the AMDR is 35% of daily energy intake from protein. Recent American and Canadian survey data revealed that adult males consume about 71 to 100 grams of protein per day, while women consume about 55 to 62 grams. Protein constitutes approximately 12 to 16% of the daily energy intake, which is within the AMDR for protein. However, some individuals may consume much greater percentages of their caloric intake as protein, particularly athletes and individuals on weight loss diets. Even though the Academy did not set a UL for protein, it did note that high protein intakes have been implicated in various chronic diseases. The health effects of dietary protein may depend on its source. As noted previously in several chapters, a plant-based diet may confer some health benefits. The National Academy of Sciences reported that high protein diets per se do not appear to increase the risk for CHD, and even suggested that such diets may be more helpful because of possible beneficial effects on blood pressure and lowering of LDL cholesterol and triglycerides. The Academy also noted that no clear role has emerged for total dietary protein in the development of cancer. However, the Academy did note that the dietary source of protein may be involved. For example, excessive consumption of animal foods such as meat may be a contributing factor to the development of disease, possibly because of a relationship to the potential high total and saturated fat content or the method of preparation. A reduction in animal-derived dietary protein has been recommended for various reasons. One point to consider is that protein in many animal foods is often accompanied by substantial quantities of saturated fat and cholesterol, which have been associated with an increased risk of atherosclerosis and coronary heart disease. Interestingly, an epidemiological study by Hugh and others reported that after controlling for specific types of fat in the diet, women consuming high-protein diets did not experience an increase in heart disease. Moreover, Hugh indicated that high-protein diets are thought to increase satiety and facilitate weight loss, which could improve cardiovascular risk factors. Nevertheless, researchers recommended caution in consuming high-protein diets given the saturated fat cholesterol connection. The worldwide report of the American Institute of Cancer Research, as discussed in Chapter 2, indicated that the evidence that red meats and processed meats are a cause of colorectal cancer is convincing. The AICR also indicated that there is limited evidence suggesting that red meat and processed red meat may cause other cancers, and that methods of preparation, grilled and barbecued, that may char meats are a cause of stomach cancer. In the United States, approximately 70% of dietary protein is obtained from animal products, with most coming from meat, fish, and poultry, and smaller amounts from dairy products and eggs. Although such a diet assures adequate protein, it is not in accord with general healthful guidelines to consume less meat and derive more protein from plant food. This ratio of animal-plant protein of 70 to 30 might be more helpful if reversed to 30-70. The Omni-Heart diet plan, as discussed in previous chapters, focuses on good carbohydrates and good fats, but it also stresses the importance of good proteins, such as those derived from plants and low-fat animal products. Table 6.9 provides some of the Omni-Heart diet plan tips to increase your intake of good protein-rich foods. For example, a glass of whole milk and a glass of skim milk both have 8 grams of protein, but whole milk has 8 grams of fat compared to less than 1 gram in the skim milk. Nutritionally, skim milk is 40% protein calories, while milk is 22%. Thus, the skim milk is a better choice. Soy protein has been recommended as a meat substitute, and as noted in Chapter 2, foods rich in soy protein may carry a health claim suggesting benefits in preventing heart disease. Modern processing techniques fortifying soybeans with methionine have helped to make a complete protein. Soy products derived from soybeans include tofu, tempeh, miso, soy nut butter, and soy milk. Many of these products have been added to school lunches as soy-based burgers and hot dogs to decrease fat intake. For health benefits, the FDA-approved health claim is based on an intake of about 25 grams of soy protein a day. Other than consuming high-quality protein and being virtually free of saturated fat and sodium, soy contains a number of substances that might confer health benefits, including isoflavonoids, phytosterols, and omega-3 fatty acids. Some have suggested that most health benefits are believed to be due to the isoflavones, genistein and diazine, as they may function as phytoestrogens or weak estrogen-like substances and possibly have protective effects against heart disease. However, we will see research indicates that the soy protein and soy isoflavones provide greater benefits when combined with either occurs alone. Whole soy foods are recommended as they naturally contain about 2 milligrams of isoflavones for every gram of soy protein. Isoflavones may be lost in highly processed foods, and isoflavone supplements may not contain protein. Check the food label. Soy should be one of the first 3 ingredients. As you may recall, the liver is the major organ involved in protein metabolism. Excess dietary protein may be converted to carbohydrate or fat, with the excess nitrogen being converted to urea for excretion from the body via the kidneys. High protein diets may also lead to excessive production of ketones, which also must be excreted by the kidneys to prevent an increase in blood acidity, known as ketosis. Thus, excess dietary protein would appear to stress the liver and kidney. Diets containing moderate amounts of protein do not appear to adversely affect liver or kidney function, although kidney function progressively declines with aging. According to the National Academy of Sciences, the protein content of the diet is not responsible for this decline. Some research has also shown that athletes on somewhat high protein diets may not be adversely affected. However, certain individuals should be concerned with the protein content in their diet. Eisenstein and others noted that caution with high protein diets is recommended in those individuals who may be predisposed to kidney disease, particularly in those with diabetes mellitus. The American Diabetes Association recommends that diabetics consume no more than the daily RDA for protein. Individuals with chronic kidney disease need to monitor protein intake under guidance from health professionals. Individuals prone to kidney stones should also moderate protein intake. High protein diets may lead to more acidic urine, and the more acidic the urine, the greater the excretion of calcium. The Academy notes that most common form of kidney stones is composed of calcium oxalate, and its formation is promoted by an acidic urine with high concentration of calcium and oxalate. As noted, excess dietary protein may increase urine acidity, which may be attributed to the increased acids in the blood associated with the oxidation of the sulfur amino acids. The National Academy of Sciences indicates that calcium might be absorbed from the bones to help buffer the acidity. If so, excess calcium losses could be led to decreased bone density. However, the Academy indicates that whether this bone reabsorption leads to bone loss and osteoporosis is controversial, but does cite recent studies showing no association between protein intake and bone mineral density. The Academy suggests that the diet may be the key. Studies present conflicting data as to whether animal protein, as contrasted to plant protein, decreases bone density, with an increased risk of osteoporosis and bone fractures. Protein is needed for bone development at all stages of life, but excessive intake may lead to increased calcium losses. Although this does not seem too substantial a loss given the RDA for calcium, it could be significant for those on a high protein and low calcium diet. The Academy notes that inadequate protein intake itself leads to bone loss, but increased protein intake may lead to increased calcium intake, and bone loss does not occur if calcium intake is adequate. Bonjour notes that experimental and clinical published data concur to indicate that low protein intake negatively affects bone health, and indicates that dietary proteins are as essential as calcium and vitamin D. Because both urea and ketone bodies must be eliminated by the kidneys, dehydration could occur from excessive fluid losses. Such an effect could compromise the ability to deal with exercise in the heat. Additionally, Johnson and others found that increasing the protein content of the diet from 17 to 31% of energy would significantly increase the resting energy expenditure, an effect they suggested could contribute to the development of heat illnesses when exercised under warm conditions. Both of these are possibilities, and the implications are discussed in Chapter 9, which when we discuss fluid balance and temperature regulation during exercise. Both bone health and osteoporosis prevention. The key appears to be getting enough of both protein and calcium. The topic of calcium balance is presented in Chapter 8. Does the consumption of individual amino acids pose any health risk? Amino acids do not exist free in foods we eat, but are complexed with other amino acids to form protein. The National Academy of Sciences noted no evidence that amino acids derived from usual or even high intakes of protein from foodstuffs present in health risk. Although no UL has been established for amino acids, the Academy indicated that the absence of a UL means that caution is warranted in using any single amino acids at significant levels above that normally found in food. Extreme consumption of individual amino acid supplements may pose a health risk. Free amino acids have been manufactured to serve as a drug, to be given to patients intravenously for adequate protein nutrition. They may also be used as food additives to enhance the protein quality of foods deficient in specific amino acids. They are also marketed as dietary supplements and sold separately or in combination with other amino acids. As dietary supplements, purity and safety are not guaranteed. In 1989, a serious epidemic of eosinophilia myalgia syndrome, or EMS, a neuromuscular disorder characterized by weakness, fever, edema, rashes, bone pain, and other symptoms, was attributed to an L-tryptophan supplement contaminated during manufacturing. The long-term effects of even moderate doses are also known, as noted previously, in regard to arginine and its effect on HGH secretion. One problem is that excessive reliance on free-form amino acids in comparison to dietary protein may lead to a diet deficient in key vitamins and minerals that are normally found in protein foods, such as iron and zinc in meat, fish, and poultry. Some evidence from human and animal research indicates individual amino acids may interfere with the absorption of other essential amino acids, suppress appetite and food intake, precipitate tissue damage, contribute to kidney failure, lead to osteoporosis, cause gastrointestinal distress such as nausea, vomiting, and diarrhea, or create unfavorable psychological changes. In a review, Barrett and Herbert indicated the Federation of American Societies of Experimental Biology criticized the widespread use of amino acids in supplements, noting that they were being used as drugs for pharmacological purposes, not for nutritive purposes. In this regard, FASEB notes that there is little scientific support for the use of amino acid supplements for their stated purposes, and that safety levels for amino acids have not been established. So what's the bottom line? At present, there are inadequate scientific data to support either an ergogenic or health benefit of supplementation with individual amino acids in the healthy individual. Adequate amounts of each amino acid may be obtained in a diet containing protein in amounts consistent with a prudent healthy diet. And because such a diet may confer some benefits relative to physical performance and health, it should be the source of amino acid nutrition. Additional research is needed to evaluate both the ergogenic effectiveness and the health implications of supplementation with individual amino acids. Although consumption of adequate protein or protein carbohydrate preparations during exercise training may provide a milieu conducive to muscle protein anabolism, current research is preliminary and insufficient to support an ergogenic effect of such preparations, including whey protein and colostrum on resistance or aerobic endurance exercise performance. Central fatigue during prolonged aerobic exercise is hypothesized to occur when BCAA levels are decreased. BCAAs normally compete with free tryptophan for entry into the brain. Free tryptophan increases serotonin production, which is believed to induce fatigue. Thus, an increased free tryptophan BCAA ratio may induce central fatigue. Although several interesting hypotheses have been proposed, individual amino acid supplements are not currently considered to be effective as a means of improving physical performance. Creatine loading may be an effective means to increase muscle levels of both phosphocreatine and free creatine, consuming about 20 grams daily, and 4 equal doses of 5 grams each for 4 to 5 days has been shown to be an effective loading protocol. Increased muscle creatine levels may be maintained with a dose of 2 to 5 grams daily. Research with laboratory-controlled, repetitive, short-duration, high-intensity exercise tasks designed to mimic sports performance suggests that creatine may be an effective ergogenic aid. Research findings are somewhat equivocal regarding the ergogenic effect of other protein-related supplements such as H&B and beta-alanine. Additional research is needed to document an ergogenic effect of creatine in actual sport competition and to help resolve the ambiguity with other related supplements. Dietary deficiencies as well as the dietary excesses of protein and amino acids may interfere with optimal physiological efficiency, which may lead to impairment of health status. And that concludes our session today. We will be talking more about protein supplementation in our next session. Hope you have a great day today. Talk to you soon.